Go ahead. Try it right now. Use your own fingers and tickle the bottom of your foot or under your arm. Nothing happens, right? Maybe a tiny giggle if you're imagining your friend doing it, but nowhere near the same explosive, can't breathe laughter that happens when someone else tickles you. This isn't a coincidence, and it isn't because you're not ticklish. It's because your brain is doing something incredibly clever behind the scenes, something that's been protecting you since before you could even talk. Today, we're breaking down exactly why you can't tickle yourself, what's happening inside your brain when you try, and why this weird quirk of biology actually says a lot about how your mind works. First, let's clear something up. Tickling has nothing to do with sensitive skin. Your nerve endings fire the exact same way, whether you touch your own foot or someone else touches it. The signal travels up your spinal cord to your brain identically in both cases. So if the physical sensation is the same, why does one make you laugh hysterically and the other does nothing? The answer isn't in your skin at all. It's in your brain, specifically in a small but powerful structure called the cerebellum. The cerebellum sits at the base of your brain, and one of its main jobs is predicting the consequences of your own movements. Think about it this way. Every time you move your hand, your brain has to predict what that movement is going to feel like. This is actually essential for survival. If your brain treated every self-generated sensation as new and surprising information, you'd be overwhelmed constantly. Every step you take, every time you touch your own arm, your brain would be sounding alarm bells. So instead, your brain runs a kind of internal simulation. Right before you move, it sends a copy of that motor command to the cerebellum, which is called an efference copy. It's essentially your brain's way of saying, hey, here's what I'm about to do. Get ready for the sensation that's coming. Because the cerebellum already knows your finger is moving toward your ribs, it pre-cancels the sensory surprise. By the time the actual touch happens, your brain has already dampened the response. It's old news before it even occurs. This is the same reason you don't notice the feeling of your clothes against your skin all day, or why you can't surprise yourself by jumping out from behind a corner. Your brain is constantly filtering out sensations it can predict. Now, here's the key piece. Tickling as a sensation actually depends on unpredictability. When someone else tickles you, your brain has no advance warning. It doesn't know exactly when the touch is coming, where it will land, or how much pressure will be applied. That uncertainty is what makes the sensation so intense. Your nervous system treats it as something worth paying urgent attention to. Researchers believe this connects to an old evolutionary alarm system. Sudden, light touches in vulnerable areas, your neck, ribs, belly, feet, could signal a crawling insect or an unknown threat. Your nervous system reacts fast and dramatically, which is part of why tickling can feel like a mix of laughter and genuine panic at the same time. When you try to tickle yourself, none of that uncertainty exists. Your brain already knows the exact timing, location, and pressure because it generated the movement itself. No surprise means no alarm response, which means no intense tickling sensation. This isn't just a theory. Scientists have actually tested it directly. In a well-known study from University College London in the late 1990s, researchers had participants use a joystick to control a mechanical arm that would tickle their own palm. When the robotic touch happened in real time, with zero delay, participants reported it felt far less ticklish, just like tickling themselves with their actual hand. But then the researchers introduced a small delay, just a fraction of a second between the joystick movement and the robotic touch. And here's the wild part. The longer the delay, the more ticklish the sensation became, until at a long enough delay, it felt almost exactly like being tickled by another person. Why? Because once there's a delay, the brain can no longer perfectly predict the timing. The connection between your action and the resulting sensation gets broken, and that little gap in certainty is enough to bring the tickle response roaring back. This experiment is huge in neuroscience because it proves the brain's self-monitoring system, not the skin, is what controls ticklishness. This self-prediction system isn't just some quirky tickle mechanism. It's a window into something much bigger about how your brain distinguishes me from not me. This same system is part of why, in some mental health conditions like schizophrenia, the brain's ability to label self-generated actions can break down. Some studies have found that certain individuals with schizophrenia can actually tickle themselves because their brain's internal prediction system doesn't dampen self-generated sensations the way a typical brain does. Their thoughts and inner voice can sometimes feel like they're coming from an outside source for the same underlying reason. In other words, your inability to tickle yourself isn't a flaw. It's actually proof that your brain's self-awareness system is working exactly as it should. So next time you try to tickle yourself and feel nothing, remember, that's not a failure. That's your cerebellum doing one of its most important jobs, constantly predicting your own movements, so you can tell the difference between your own actions and the unexpected actions of the world around you. If you found this interesting, let me know in the comments what other strange quirks of the human brain you want explained next.